Alrighty, so here in section 7.2, we're still going to be talking about the sampling distribution of the mean. And there wasn't a whole lot of new concepts introduced here. It's just sort of combining all the stuff we've already learned into one. Right, so we're going to hop straight into some problems. The first one is going to be to find the standard score for the following data. And really, one more word in there makes this make more sense. Right? So the fact that we're finding the standard score for an X bar, right, rather than just an X value, is what clues us in that it belongs into this section, other than the fact that I just wrote it down when I said we were working on this section. Right, but if you see it elsewhere, that X bar gives us the hint that we're looking for a standard score in the sampling distribution. Right, and what that means, right, if we recall, the standard score for something means to take that something, subtract the mean of that something's distribution, and divide by the standard deviation of that thing's distribution. Right, so in order, that's the word I was looking for. In order to find the standard score for an X bar, we need to know mu X bar and we need to know sigma X bar. Right, so mu X bar we learned before is just exactly the same thing as mu population. Sigma X bar we learned last time, that should be sigma population, is sigma of the population divided by the square root of the square root of the sample size, which I plugged into a calculator and is about this much. Right? Though a better thing to do, rather than simplifying here, a better thing to do would be to plug into your calculator all of these steps before you round. Right? Because secretly, when you're doing this, you're actually rounding. I've been very bad about doing this because it often doesn't matter quite as much for us. But it would be better to put in 22 divided by the square root of 30 here and let the calculator round it with way more decimal points than we really want to type out. But when we do that, we get that this guy is approximately 0.249. So that's the standard score, right? This would be what we would want to do if we want to use the table to look up a probability, right? Here's what we want to do because it's what was asked for us. But it might be a useful thing to know how to do if we want to look up the table to find a probability. If we have some reason why we need to use the standard normal, if we want to compare this to something from a different population, right? One of the quick and dirty ways to compare two populations is to compare their standard scores, right? Just comparing the two averages doesn't necessarily mean something, or it doesn't mean as much relative to a different population. So that's the sort of thing that we would want to find a standard score for. So that's one thing we might do. So another thing, I'm going to cheat. We're going to freeze. Aha, there we go. Okay. So I'm going to cheat and I'm going to pull in the word problem from last section. So I don't have to write all that out again. Come on. Stop that. Right, so we're in this situation and we figured out before that X bar was normal, was a normal distribution with a mean of 5.7 and a standard deviation of 1 or 0.155. And so we might be asked a question here that might look like, what is the probability that a sample has an average of 5.5 or less? Right? So if we were asked a question like that, what's the probability that a sample has an average of 5.5 or less? Right? That's very different from being asked, what is the probability that a child learned to read at age 5.5 or lower? Right? That's sort of the two different things. Is the population, if we were asking a question about the population, the question would be, what is the probability that a child, an individual in the study, had did whatever the study was about at a particular time, right? This problem that asks, what's the probability that a sample has some particular value, is how we know that it was asking about a sampling distribution, right? Even if we didn't have this question here, right? Because this question came from last section. Even if we didn't have that there, if we had this problem that asked about probabilities having to do with properties of a sample, then we would know that we need to find the sampling distribution, right? If we hadn't already. But to answer this question, we could go to our calculator. Remember, that's the command normal CDF. Right, this is, insert something here above it. Right, this is asking the question, what's the probability that X bar is less than or equal to 5.5? Right, so if we recall from before, we need a left bound first, and we don't have one, so we're going to replace it with infinity. Right. Then we need a right bound, which is the 5.5. Then we need our mu and our standard deviation. Right, and we can plug that in and figure out, and our calculator will tell us how much it is. Our other option would be to convert it to the standard normal and look on a table. But this is something that I strongly recommend getting comfortable with. And I'm going to take a detour real quick. This may be repeating something, but I'm not certain if the first time I explained it had to get cut out because of technical difficulties. But if you go to your calculator, the way you get that 1E99 is it's above the comma button here. It has two capital E's in blue, so we need to hit second. That button under the two capital E's, and that gets us the little, the small capital E. So I just want to make sure I pointed out how to get that on your calculator, because I wasn't sure whether that got cut out, right? So let's do another problem. Oops, 3. So a website gets an average of 50 hits per day with a standard deviation of 4.2 hits per day. What is the probability that the average hits per day for September is more than 52? Right? So this is a tricky question because it doesn't actually say anything about samples in here. So one thing that can still clue us into that is we're asking the probability for an average, right? We're not asking for the probability of a particular value happening for an individual. We're asking, so here individuals are days, right? So we're not asking for the probability that there is a particular number of hits per day in a particular day, right? So the alternate question might be, what is the probability that they get more than 52 hits tomorrow, right? So this one is asking a question about the website that we can't actually answer because we don't know enough about the website, right? But this is asking about a specific day, right, which are the individuals in the population that we're dealing with. And this question is asking about an average rather than a particular value, right? So this is just asking about 52 hits on a single individual, whereas the actual problem that we're going to answer is asking about the average that we're getting on something that's not an individual, right? So that's what clues us in that we're in the right section with this one, right? That we're dealing with a sampling distribution, right? So we know we're going to be dealing with X bar. And to figure out stuff about X bar, we need to know whether it's normal or not. Now, the word normal doesn't show up anywhere in here, so we don't know that the population is normal. So that means that in order to continue, we need to figure out what N is, right? So again, this comes down to recognizing that days are the individuals in this subject, right? They're looking at a particular day and getting a value then, right? And then we realize that the question is asking about September, right? So this is where they're sneaking the sample in, because September is made up of more than one individual, right? An individual is a day. September is 30 days long. So September, it's not a random sample of 30 days, right? It's 30 days that are related to each other somehow. But it is a sample of 30 days, right? And since the sampling distribution talks about every possible sample, the month of September is one of the samples of 30 days in the population of every day that ever existed that we have, right? So it doesn't matter that it wasn't random. It's still a sample that is 30 individuals big, right? So N equals 30. So that tells us that we know that this guy's normal, which is good. Otherwise, we'd be stuck, right? And we know that mu for the population is 50, right? Average of 50. And the standard deviation of the population is 42. Not 42, 4.2. Right, so that means that mu of x bar is going to be 50 again. So we know we got a normal 50 there. And we know that sigma of x bar is going to be 4.2 divided by the square root of n. Right? And so we can simplify that if we really want, right? If part of the question was asking what that was, we might want to round that to some good number of decimals. But we can also leave it where it is, right? If I were going to put this question into my calculator, right, we're looking at the probability that x bar is greater than 52, right? That's going to be the normal CDF of our lower bound, right? And here 52 is the lowest we want x to be, right? And then our upper bound, we don't actually have one of those, so we replace it with positive infinity, right? Our mean is 50, and then if I was plugging this into my calculator, that was a weird way to pronounce that, but you know, whatever. If I was going to plug that into my calculator, I would just plug in sigma like that, right? Again, that lets the calculator do the rounding, and the calculator can keep far more digits in its mind than I would care to type out or write out at any given moment. So that's a good way to make sure you get some slightly more exact numbers, is to not round until you absolutely have to. Right, so again, this would be something you plug into your calculator, and you get a value back for it. So that's how we're dealing with these sampling distributions. We have one more section here in this chapter. We're going to talk about doing the same sort of thing with proportion instead of mean, right? And then we're actually going to hop into some of that analysis stuff that we talked about doing at the very beginning of the semester. We're actually going to get into analyzing some of this data and figuring out how we can know things about the population just by learning things about the sample. And the sampling distribution is a good start. But we're gonna get some more tools in the next couple chapters. So I'll see y'all then.